We're on page 1 of this section. We have to fill in this box where we have information about parent functions for square root and cube root functions. What's going on here is you're going to be graphing a bunch of new graphs. You know, you're used to lines, you're used to parabolas, and absolute values, the v's. And now you're going to need to get used to some square roots and some cube roots. And they just want to highlight the basic idea for a basic square root. So for the first part, if we're talking about square root x, the domain is x is greater than or equal to 0. This is consistent with the idea that you don't do square roots of negative numbers. So the domain, the thing inside the square root, has to be non-negative, which really means positive or 0. The range is y, and the range is going to be the same. Y is greater than or equal to 0. And that's because square roots give positive answers. Okay, if you stick in 0, you get 0 as an answer. But otherwise, it gives positive answers. Now, there's a little contrast with cube root. So the next bullet's about cube root x. And here, the domain and range are both the same, and they're both all real numbers. This is because cube roots work with negative numbers. We've seen this before in the prior sections. So you can do, let's say, cube root of negative 8. So you can stick in the domain negative numbers. And when you do a negative number in a cube root, you get a negative answer. So for my example, cube root of negative 8 is negative 2. So negative numbers work in the domain. Negative numbers also work in the range. Now, if you want to be, you want to look slick, instead of all real numbers, there's this r with a double back that you can write. Or you can say, why would I waste my time doing that? Doesn't really matter. So let's move down to example 1, where we have to graph a square root function. Now, you're supposed to make this graph, and then it says compare the graph with the graph of y equals squared x. So I'm going to do the main work here for y equals 2 times square root of x. We're going to do that in red. So you begin with a table of values, and x, y chart, t chart, whatever you want to call it. You plug in 0 for x, you get 0 out for y. If you plug in 1 for x, you'll get 2 out for y. And then they put in some other numbers, and you need a calculator to do these. And, it's not exciting work, but you should make sure that you know how to make your calculator do square roots correctly. When you put in 4, you don't really need a calculator for it, although nobody will know if you used one anyway. But when you put in 4 into the square root, you get 2, but then it's 2 times that, so your answer ends up being 4. Well, we can go ahead and make ourselves some dots off of that. So 0, 0 is favorite dot on the origin there. 1, 2 is up here. 2, 2.83 is up there-ish, working on close to 3. 3, 3.46 is there-ish, essentially 3.5. And 4, 4 is there. Dots. And I'm going to go down to this domain statement next, and then I'll go fill in the dots. It says the radicand, and that's an exciting word. It means the inside. Of a square root is always non-negative. Non-negative is so annoying. It means greater than or equal to 0. It's the right word, but it's tedious to read. So the domain is x is greater than or equal to, x is greater than or equal to 0. The range is y is greater than or equal to 0. This comes straight off of that box above. So we know the domain is starting at 0 and going up, and we're going to follow this curve. It's not a straight line. Do not get out your straight edge. Do not get out your student ID card or parents' credit card you took from them. Well, no, whatever. Connect with the smooth curve. Throw an arrow on the end because it's going to keep going, but you're not going to keep graphing it. And then On the bottom it says the graph of y equals 2 times squared x is a vertical, and the word here is it's a vertical stretch, and that's because it's multiplied by 2. This is just like how a line with a slope is steeper than 1, like y equals 2x is steeper than y equals x, or we did that on the absolute value v's. We also did that with parabolas a tiny bit, where if it's like 2 times x squared, it ends up being taller and looking narrower. So you were meant to go back at some point and compare the graph with the graph of y equals squared x. So I guess filling in that word at the bottom is a comparison. It's not very exciting. Just to make sure that you can have a chance to see it, I'm also going to draw y equals square root of x on the grid here. And I only did the nice numbers. I didn't do all the decimals you get from a calculator. But you can see that the red one is twice as tall, because the red one was y equals 2 times square root of x. And the blue one is y equals square root of x. So the red one is twice as tall as the blue one. That comes from the vertical stretch. In any case, thanks for watching.